Okay, we have seen how to find out the limiting circle, point circle, axial family, and we have considered the standard x-axis was the line joining centers and y-axis was radical, but that is easy case. Let me give you a problem where you numerically try to do this and understand everything. I mean, it is very simple. So the problem statement. Find the limiting circles. Belonging to family with respect to S1 x square plus y square minus 10x minus 9y plus 54 is equal to 0. S2 x square plus y square plus 6x minus y minus 2 is equal to 0. Also find equation of smallest orthogonal circle to S1 and S2. Resume recording. You have been given two circles S1 and S2. Therefore, you should be able to find out the radical axis. The radical axis is S1 minus S2 is equal to 0. Orally also you can do that. Minus 16x minus 8y plus 56 is equal to 0. Now if you divide by minus 8, you get 2x plus y minus 56. This is your radical axis. Now you want zero radius circle out of this family. So maybe S2 has some little smaller numbers. Therefore, family is given by x square plus y square plus 6x minus y minus 2 plus lambda times 2x plus y minus 7 is equal to 0. These are the circles, coaxial family of circles with respect to S1 and S2. And now we want radius to be 0. So maybe you can write one more step like this, y square plus 6 plus 2 lambda times x plus minus 1 plus lambda times y minus plus minus 2 minus 7 lambda is equal to 0. Okay, so this is what is your quadratic. You want radius is equal to 0, so radius is g square, so minus 3 plus lambda bracket square plus minus 1 plus lambda by 2 bracket square, or maybe okay, plus 1 minus lambda by 2 bracket square minus c plus 2 plus 7 lambda should be equal to 0. This is the only difficult calculation, and it is not supposed to be difficult because numbers are good. However, this minus also I can eliminate. So lambda square plus 6 lambda plus 9, that is the first part, plus lambda square minus 2 lambda plus 1 whole divided by 2 plus 2 plus 7 lambda is equal to, if I multiply by 2 and put all the quadratic in lambda square, how much? 2 plus 1, 3 lambda square plus 12 vaja, what is this? 2 lambda, 12 vaja 2 म्हणजे 10.
I wanted to by 4.
Yeah?
The middle expression, the denominator should be 4.
4. Okay, so this is 5 lambda square, 4 plus 1, 6 चोक 24 वजा 2 22 आणि 7 29. I don't know whether it is correct or not. You have to cross check. 36 37. No, again this 4 will go here. Mesiga. So 4 lambda square plus 24 lambda plus 36 plus lambda square minus 2 lambda plus 1 plus 8 plus 14 lambda is equal to 0. I think that is a good idea to write it. Now I think I will be correct. 5 lambda square, this is 22 plus 14, then
Sir, it should be 28.
Sir, the 28 lambda पाहिजे.
9 चौक 36, 7 चौक 28. Therefore, what is this lambda then? I should not perform this type of calculations when recording also. I am recording also. Anyway, 24 वजा 2 22 अधिक 28 50. आता बरोबर आहे? 37 आणि 8 45. Lambda square plus 10 lambda plus 9 equal to 0. Lambda is equal to 9 minus 9. What is lambda value?
-1 and -9.
Minus 1 or minus 9. That gives you 2 circles. Those are the point circles. Therefore, centers are going to be their coordinates. So if I put -1 in place of lambda, then I will get first circle as x square plus y square minus 1 if I put plus 4x minus 2y plus 5 is equal to 0. And second circle, if I put -9, I will get x square plus y square minus 12x minus 10y plus 61 is equal to 0. And if you happen to find the centers of them, it is -2, 1 and 6, 5. Okay, and then 4 plus 1, 5 minus 5, 0. 36 plus 25, 61 minus 61, 0. Okay, so these are the 0 circles. These 2 points as a diametrically opposite point. The equation of circle is, hello? हो येतो. तुम्ही ठेवू शकाल काय का गेटवर? नेतो. Thank you. This is the equation of circle with these 2 points as a diameter. That is the. Now, what is the geometry? Geometry is some line like this is there. There is one point circle here whose coordinates -2, 1, 6, 5. This is your orthogonal circle passing through that all orthogonal circles, and you want the one which is like this diameter. So the difficult part in that is only this, solving quadratic, and therefore you should be able to do it very. Forget about my mistakes, but you should not make any mistakes while doing calculations. So it is wise to jump from here to here directly. It is better to write down this step and then do it. Let me give you one, because you took a lot of time in solving this. Now you have to do it fast. One more. S1 x square plus y square plus 5x minus 16y plus 54 is equal to 0, and radical axis is x minus 2y plus 1 is equal to 0. Find both. ठीक आहे, माझे कुरिअर आले तेवढं मी घेऊन येतो खाली जाऊन. Okay, answer for this, the first point circle is x square plus y square minus 8x plus 10y plus 41 is equal to 0. Second point circle is x square plus y square plus 4x minus 14y plus 53 is equal to 0. And orthogonal circle, smallest orthogonal will be x minus 1 square plus y minus 1 square is equal to, what is the radius? This 36 अधिक 9 45. Is that correct? 43 किती 45. So x square plus y square minus 2x minus 2y plus or minus 43 is equal to 0. These are the three things. Now if I ask you, another problem in this could be, I give you two circles and ask you to find out an orthogonal circle passing through a given point. Let us see. So let my first problem S1 and S2 be there like that only. First problem S1, S2. Okay. So if these are the two circles, find orthogonal circle to S1 and S2 passing through. Passing through question 1 origin, question 3 comma minus 2. Get the answers. I don't have answers. Depending upon majority, I will decide which is the correct answer. Okay, let me say it again. Now we want orthogonal circle to S1 and S2 passing through origin or 3 comma 2. These are the two different problems. Origin is easy, 3 comma minus 2 is little difficult. The best method seems to be you quickly find out the radical axis, which happens to be 2x plus y minus 7 is equal to 0. Therefore, y is equal to minus 2x plus 7. if you put any parameter for x which is k, then k comma minus 2k plus 7 is a point on radical axis that will be the center of required circle. Now from this center with S2, because numbers in S2 are little smaller, you find out length of tangent square. So this is where we have found out length of tangent square. By putting this point in S2, we get a square plus minus 2k plus 7 bracket square plus 6k plus 2k plus minus 7 minus 2. This is the length of tangent square, and this should be equal to distance of 3 comma minus 2 from k comma minus 2k plus 7 square. That is what is this quantity. And therefore you will find that when LHS and RHS you make it like this, 5k square gets cancelled and you get k is equal to 22 by 11. By putting that value back into the center, you get center of the circle, and putting k value either in this LHS or RHS, you get the radius of the circle, and you can report the orthogonal circle without actually finding out the limiting circles or the equation of line joining circles. Is it 47? Let us find of MM. Consider points AI, xi, yi. 1 less than equal to I less than equal to n. Centroid of these n points is point G, x bar comma y bar, which is x1 plus x2 plus xn divided by n, comma y1 plus y2 plus yn divided by n. Let k be a fixed real number. Find the locus of point P. Such that sigma I goes from 1 to n PAI square is equal to k. So of course k is a positive real number. Describe this locus. Okay, do it. Okay, the locus of this is circle with center at centroid. Okay, and radius equals x bar square plus y bar square minus inside bracket sigma I goes from 1 to n xi square plus sigma I goes from 1 to n y I square minus k upon n. That is what is written in my notes. What do you get? Is it correct?
Sir,
Sir, that's
याचं
the root.
कशाचं रूट?
सर रेडियस मध्ये
Radius.
त्याचं
Radius square. Sorry, square of radius. Radius square is equal to this. This is constant. This is minus g square, my plus f square minus f square minus c. Okay. Array, do you get this or you want me to write? I mean, it is simple. You just consider any point p x dash comma y dash and solve it as a locus problem and then collect the like terms and you will get it. Next, problem point number 48. A variable line L is passing through a fixed point A comma B. The locus of put of perpendicular from another fixed point B C comma D is a circle. I mean, we are supposed to verify this, so I am giving you a statement. It is a circle with AB as a diameter. Verify whether it is correct or not. I mean, we can always convert this problem into a numerical problem, and if you know this fact, then you can get the equation of circle very quickly. Otherwise, it will be, I should have done that, but now cat is out of the bag. Resume record. You have a fixed point A comma B. This is your line. Suppose you have fixed point A comma B here, and there is C comma D somewhere here. Here. So from C comma D, you are supposed to drop perpendicular on this line, and this is your point. Locus of put of perpendicular. So locus of P x dash comma y dash. This is A and this is B. So now as this line varies, it moves by passing through A comma B always. It will be here. This is your P, and then this angle is always 90 degrees. If the line is like this, it's going to be here. This angle APB is always going to be 90, and therefore that locus is going to be a circle with AB as a diameter. With AB as a diameter, we will have that locus as a circle. Easy. So if you have been given a problem like this, you should directly write down the equation of circle, because A and B both are known to us. You need not have to worry about it. It will be. Otherwise, this is extremely difficult, because this is a variable line. You have to assume slope m. M varies. Then you have to find out put of perpendicular, coordinates of put of perpendicular, let x dash y dash, and then I mean, if you do all those calculations also, you will get the same equation of circle. Okay. Now let us do. Almost everything is done. Few things I am not doing because they are so easy that you can do it otherwise. I mean, even if we don't do right now, if they are given to you, you can do it quickly. So now only one thing which is remaining is, suppose, let me give you one circle, x square plus y square minus 8x plus 10y. Okay, now let me make the radius of this circle quite big. 64 plus 9, 16 plus 25 is 41, and if I want radius to be 100 minus 50, what happened to my cursor? Minus 59 is equal to 0. This is the circle given to you, and hopefully point P, say 2, 3. I want it to be near the center. It is going to be, is in the interior. Find equation of chord such that P is midpoint of chord. Okay, so if point P is inside the circle, then what will happen? There will be many lines passing through P, and all of them will be chords, but there will be only one line which will be, in that case only P is going to be the midpoint of that chord. Find that equation. X minus, answer is x minus 4y, so 2 and 12 plus 10 is equal to 0. This is easy problem because circle is a symmetric figure. Center is at 4 comma minus 5, and we have been given the 2 comma 3. So slope of this line we can find out, and slope of this we can find out. By geometry we know that this is going to be the midpoint. I want to make it little difficult. Say for example, x square plus y square plus 2xy minus 4x plus 5y plus 7 is equal to 0. Okay. And I give you a point P, easy point, 1, 2. And I want an equation of chord passing through 1, 2 such that 1, 2 is a midpoint with respect to this conic. Say for example, I don't know what this conic is, but suppose it is ellipse, and 1, 2 is here. Okay, then either you draw a sketch correctly or do something so that we want equation of this line. And I think it is going to be unique because every other chord that you will draw, except that if you are at center, you may get two like that, but otherwise you will get only one. We wish to do that because this is easy. This circle business is easy. Maybe this question will come for parabola, ellipse, hyperbola. So let us work on that because we have been doing really easy things so far. So let us do this little involved and find out. So I give you time to get this also in place and then we will do it together. Resume recording. Answer for this is काय तुमचा आन्सर आले 2x plus 11 ना
Oh, sir.
20. This is the answer for this question. Now let us play game. Chalo. Who will give me the conic section? अरे इथं मी x square y square घेतला. चला कोणतरी सांगा मला conic section. S is equal to चला कोण सांगते? Sania, you gave very good answer. Tell me what is the conic section that we should take.
5x square plus y square plus 23x minus
एवढे मोठे
59
कशाला तुम्हालाही कॅल्क्युलेशनला त्रास होणार आहे मलाही होणार आहे छोटे छोटे आकडे दे
minus 2x
2x
plus 4y minus 3xy plus 2 is equal to 0.
0 and point
5,0.
5. Okay, you start doing, I will start doing my work. Let us see. These days I am not doing my calculations correct. Let me check. Pause recording. Okay. So we want to find out equation of chord in terms of midpoint. To find equation of chord in terms of midpoint. Okay, so the curve given S is x square plus by square plus 2hxy plus 2gx plus 2fy plus c is equal to 0, and let point P be x1 y. Okay, that is our setup. Now if S is suppose something like this and P is somewhere here, then we said that chord is going to look like this, and therefore maybe we will have a point somewhere here so that it is easy to visualize. This is our x1 comma y1. Corporation से आले. अरे 2 मिनिटं होल्ड करा. कॉर्पोरेशनचे लोक आले, चेक करतो. हाँ. Suppose x1 y1 belongs to this line. So any other point on this line, this is where we are going to use the parametric notation of straight line, parametric form of straight line. Any point here will be x1 plus r cos theta, comma y1 plus r sin theta. Any point on that line. What is r? R is any distance from x1, y1. And what is theta? It is inclination with positive x-axis. Okay. So why is this notation important to us now? Because this point of intersection is whatever r that we have from x1, y1. This point will have exactly opposite r. That is the property we will eventually exploit. And therefore now we should start our work by this. This is the point which we want to represent on the conic section. Hence this point should satisfy this equation. So a into x1 plus r cos theta bracket square plus b into y1 plus r sin theta bracket square plus 2h x1 plus r cos theta into y1 plus r sin theta plus 2g x1 plus r cos theta plus 2f into I1 plus r sin theta plus c is equal to 0. Okay, it should satisfy that point. And therefore what we end up getting is square into some term plus 2r into some term plus constant is equal to 0. It is r quadratic. Okay. And now what we want? We want that slope of the line. We want that slope of the line which makes this thing to happen. What? R is equal to opposite of R. We want that slope. We are interested in that theta such that sum of the roots become 0. We want that theta such that sum of the roots become 0. Therefore, this bracket we want equal to 0. And hence find tan theta. If you make this bracket equal to 0 after expanding this, we are interested in that theta such that this bracket becomes 0. And that theta, tan value of that is our slope. The moment you have this slope with you, we will be able to get the equation of straight line. Now you will think, sir, our method is much smaller than this. But first do this calculation. Then I will show you why this method will give you faster equation of line compared to you. Let me collect r terms. It is 2a cos theta x1 from the first bracket plus 2b sin theta x2, sorry, y1.
It should be only a cos theta x1 plus b sin theta x2.
Outside, yes.
Sir.
2 is outside, so a cos theta x1 plus b sin theta y1, a cos theta x1 plus b sin theta y1 plus, what is plus? 2 is outside, h x1 sin theta plus h y1 cos theta g cos theta plus f sin theta. This is what is this bracket, which should be 0. Therefore, what we get is cos theta times ax1 plus hy1 plus g is equal to minus sin theta times by1 plus hx1 plus f, and therefore tan theta is equal to minus sine upon cos ax1 plus hy1 plus g upon by1 plus hx1 plus f. This is our slope, and therefore our equation of line is y minus y1 is equal to, or instead of that, y minus y1 is equal to minus of ax1 plus hy1 plus g into x minus x1 into by1 plus hx1 plus f. Is that right? So let us expand. And okay, let us expand LHS, let us expand RHS, no hurry. Byy1 plus hyx1 plus fy minus by1 square minus hx1y1 minus fy1 is equal to, now is equal to, I am eliminating, and with that minus sign, if I bring it to the other side, it will become positive, and therefore I can directly write plus axx1 plus hxy1 plus gx minus ax1 square minus hx1y1 minus gx1 is equal to 0. Very good. Now let us collect terms. Axx1 plus byy1, okay, plus hxy1 plus yx1. Now why are we doing this? Because they are familiar to us. These guys are familiar to us. Plus, now let us do g into x plus x1, because we were comfortable with this. But g x1 negative is available and positive is not. Therefore, we will take care while writing this negative, we will make it 2 plus f y plus y1. Again, fy1 is negative and we added one more, so we have to have two negatives. And let us add c from our pocket. That makes it t, and all negatives, if we push to the other side, we get ax1 square plus by1 square plus 2hx1y1 plus 2gx1 plus 2fy1 plus c, and that is equal to S1. T is equal to S1 is your equation of chord in terms of midpoint. That is why it is very fast. Doesn't matter what conic section you are talking about. Doesn't matter what point you are discussing. No quadratic equation, nothing. Just write LHS as your T, write RHS as your S1. T is equal to S1 is the equation of chord in terms of midpoint. That is the power of this notation. That is why these different notations are useful. x1 plus r cos theta, y1 plus r sin theta gets it into a quadratic equation in R, and sum of the roots of that quadratic equation makes it 0, gives us the value of theta we are looking for. Okay, S1 is 56%. S1 S2 . Question 1, find limiting circles. Oh, maybe let us not do this first. Question 1, find the equation of orthogonal circle. Passing through oh, 1 comma minus 2. Question 1. Question 2. Find the equation of orthogonal circle of radius 10. Question 3. Find equations of limiting circles of family S1 and S2.